Let's see. Let me bring up this document. Last time we reviewed pretty much this chapter 1. And we have covered chapter 2 completely. We haven't reviewed it, but we've covered it. And we have a chapter 3, 4, and 5. Chapter 3 is particularly long. Let's go over chapter 3. What I'm calling chapter 3. Degrees of monomials and polynomials. This is pretty straightforward. If I asked you what is the degree of that polynomial, what would you say?
I have no idea what polynomials and monomials are.
The degree is the highest exponent. So that's degree 3.
Okay.
Nothing else matters, but when you're talking about the degree of a polynomial, the only thing that matters is the highest exponent. What's the degree of that polynomial?
4.
Good. What's the degree of that?
1.
Okay. This also is a binomial because there are 2 terms in it. Okay. A monomial would be that. Another monomial would be that. Another monomial would be that. Each one of those, there's only 1 term in it. That makes it a monomial. And in every one I've circled, what's the degree in that one?
1.
About
Or 0?
that one. No. It's always the implied exponent. And when there's no exponent written, it's assumed to be 1.
Okay.
What's the degree in the second one?
1.
And the third one?
1.
Correct. So those are all monomials, and they're also degree 1. Now they don't have to be. That's a monomial right there. But it's degree 2. But the fact is, there's only 1 term there. Okay? So that's what makes a monomial, is if there is only 1 term. Alright, so we've covered that. Adding, subtracting, and multiplying polynomials. Now, a polynomial includes everything. It includes monomials, it includes binomials, it includes second-degree polynomials, third-degree polynomials, all kinds of stuff, okay?
Okay.
So, if I say, let's add 2 polynomials. That's a polynomial, that's a polynomial. If I add those together, what do you get?
5x.
Yeah, because they're both x. In other words, it's apples and apples. If I said, what do you get when you add this? What do you get? You can't add
5x, yeah.
You cannot add them. They're not like terms. You can only add like terms. The only reason we were able to add that and that was because they were both some amount of x. So they were both apples. But down here we got 2 apples and we got 3 oranges. So how do you add 2 apples and 3 oranges? You don't. Your answer is you got 2 apples and 3 oranges. Now, in other words, in order to add and subtract polynomials, we need them to be the same terms. Okay?
Okay.
What's that equal to?
1x squared.
Good. What's that equal to?
1x squared.
No, they are not the same terms. You cannot combine those. There's no way to add or subtract that term and that term. That's an apple squared. That's just an apple. Okay? So remember that. You can only combine like terms. They have to be the same. Now, that's with regards to adding and multiplying. Adding and subtracting. In other words, I cannot add 2x squared to 3x. I can't add those. I can't subtract them. One thing I can do is multiply and divide them. So let's talk about that for a second. When you are multiplying polynomials, let's take x squared times x cubed. We would not be able to add those two. But it turns out we can multiply them because they have the same base. If they have exactly the same base, then you can multiply them by adding the exponents. Okay? Like that. You with me?
Yep.
What is this equal to?
X to the 7th.
Now, you can also divide them. In other words, division is just really the inverse of multiplication. So if I said to you, what is x to the 5th divided by x to the 3rd, again, I would not be able to subtract these two things because they're different, but it turns out that I can either multiply them or divide them. What do you suppose that's equal to?
X to the 2nd.
Yeah, in other words, when you're dividing the bases, you're going to subtract the exponents, always. When you are multiplying the bases, you're going to add the exponents. Pretty simple. Is that equal to?
Just X.
That equal to?
0?
Add the exponents.
Oh, okay, so just x.
X to the 1. In other words, add the exponents and then realize that you don't really need the 1. So we don't need to write it. But yeah, it's equal to x. So when you're multiplying or dividing, as long as the base is the same, then you can either add or subtract the exponents. What's this equal to?
Can you do that because it's different bases?
What's that equal to is this. Same thing I started with.
Okay.
Because x is not the same as y, the bases are not the same, and therefore I cannot apply the rules of exponents. You gotta have the bases be the same. Okay? For example, that equal to?
2 to 13.
Yeah, and notice that that's a whole lot easier than putting that into a calculator, and multiplying them. So this rule of exponents is pretty valuable. Adding, subtracting, and multiplying polynomials, and they also meant dividing polynomials also. Now, let's talk about something. What's that equal
to? I'm not sure.
You cannot simplify that. In other words, it's equal to this. There's no way you can cross out the x's, because if I were to divide top and bottom by x, would actually end up with 1 plus 1 over x in the top, and in the bottom I would have 1 minus 1 over x. So that's what I would have. But you can clearly see that you cannot cross off the x's if anything's being added or subtracted to it. You cannot do that operation. Now, let's talk about multiplying, because this is actually a pretty big subject. Multiply this for me. So that's a polynomial, that's a polynomial. So we're multiplying polynomials.
I'm not sure.
Well, let's make it a little easier. Make that a number. Now do it.
3x squared plus 2.
Not 2. You got to multiply that by that, and you got to multiply that by that.
6.
Okay. So when it's a number, you know how to do it, right?
Yeah.
Okay, so let's go back and make it a variable. In other words, let's replace it again with x. So again, you have to multiply that by that, and then you have to multiply that by that. What do you get?
Would it just be x squared
Now hold on.
plus,
When you multiply x times x squared, what do you do with the exponents?
I don't know.
Add them, right?
So would it
When
be
I was doing
x?
x to the third times x to the fourth, I added the exponents. That's always what you do, is add the exponents. So when you multiply x times x squared, what do you get?
X to the third?
Yeah. And now multiply x times 2. What do you get?
X
X
2.
times 2 times x. So that's the answer to that. Okay?
Okay.
So it's pretty easy to multiply a monomial by a binomial. Because all you do is multiply each term by everything. Okay? Now, where people start having difficulties is when you have a binomial multiplied by another binomial. You ever heard the expression FOIL?
Yes.
Okay, here's what it means. FOIL means first, outside, inside, last. First means you multiply that by that. Outside means you multiply that by that and add it to your first thing, and you can see why that's called outside. Then you multiply the insides and add that to your first two terms, and then you multiply the last. And you add that to your first three terms. So, tell me what this becomes. What's x times x?
Is just
What's that times that?
x.
Add the exponents. When
So
you're
x
multiplying,
squared.
okay, good. When you are multiplying the same base, and it doesn't matter whether it's x or a number or y or r, if it's the same, then all you do is add the exponents, okay? So that's x squared. Now, what's the next term? And I need a sign to go with it. In other words, plus or minus.
Plus.
That's the outside. That's the O of FOIL. So what's x times 3?
X times 3. Just x times 3.
Well, yeah, 3x. We put the number in front, usually. Okay?
Okay.
Now, the inside of FOIL is this part. What's that?
So 1x.
Okay. And then finally, the last part of FOIL is those two parts. What's plus 1 times plus 3?
3. So plus 3.
Plus 3. Remember that when we're writing a polynomial, we cannot drop a positive sign. We can't just not state the positive and assume that everybody's going to assume that. In other words, if I didn't write the plus sign there, it would look kind of like this and it would have no meaning. In other words, if I wrote it like that, nobody can assume that there's a plus sign there. So if you don't put a plus or minus sign there, it makes all the difference in the world. And it's definitely a plus sign because it's plus 1 times plus 3. Now, usually when you are multiplying a binomial by a binomial, the middle two terms will combine. So I can simplify this answer. The first term, there's no other x squared. The last term, there's no other numbers. But what's 3x plus 1x?
4x.
Plus 4x. That's the answer. In other words, this is the answer you would want to give on a test for this question. Or if it was multiple choice, that's the answer you're going to see. In other words, they're never going to leave it like this because clearly I can combine those two terms. They're like terms. They're both some number of x's. I can combine numbers of x's. I can't combine an x squared with an x. And I can't combine an x with the number 3. But I can combine 3x plus 1x. Now, there's a reason they didn't put dividing there. Okay? And let me see if I can briefly describe to you why that would be the case. There's a polynomial divided by another polynomial. Now, the bottom polynomial can be simplified to 4x minus 8, but let's not do that yet. What I'm really going to do is factor the trinomial that's in the top into x minus 2 times x minus 1. That's what that becomes. And I'm dividing the whole thing by 4 times x minus 2. Well, now notice that x minus 2 cancels with that. My answer is x minus 1 over 4. Okay? So there's a lot going on when you start trying to divide polynomials. And you can't really divide polynomials adequately without covering factoring first. Okay? You've got to cover factoring. Now, factoring is a huge topic. And I'm going to cover it. No time like the present. There's no way we can spend too much time on factoring. There might not be anything in algebra as important for you to understand and learn as factoring. If there is one thing that you will always be asked on an algebra test, it's how to factor a polynomial. Okay? Now, let's talk about what factoring is. We just had a problem where x minus 1 times x minus 2 was equal to x squared minus 1x minus 2x, that's a total of minus 3x, plus 2. Okay? So what you just learned how to do is multiply two binomials together. Okay, using FOIL. And that's something you have to know how to do first. You can't even talk about factoring without talking about multiplying two binomials together. And we knew how to do this. We multiplied that by that, then we multiplied that by that, then we multiplied that by that, and we multiplied that by that. And we ended up with this. Well, what factoring is the reverse. It's starting with the polynomial and splitting it up into its two factors. And that's what's hard. And that's what we're going to spend the rest of this evening doing. Now, like I said, factoring is a big subject. We will probably be talking about factoring tonight and our next full hour of sessions. That's how important factoring is. Okay?
Okay.
Now, there are a couple of kinds of factoring. The first one is greatest common factor. Okay? If I give you an expression like and that is an expression, it's not an equation. There's no equal sign. Okay? So it's just an expression. Are you hearing all that buzzing in the background?
Yeah.
We can probably get rid of it if I call you on the phone. Is that preferable? Is it better audio for you?
No, I'm fine.
Okay. All right.
If you're okay.
I'm okay with it. Okay. So if I give you this expression and I say, what is the greatest common factor? What it means in this case is 2x. That would leave a 2x plus 1. Sounds like we have a buzzsaw going on in the background.
Yeah, I think somebody's like cutting their the grass on the lawn and it's really annoying.
Oh, okay.
I'm so sorry.
No problem. I can certainly live with it. But
Here, I'm just gonna close the window.
that'll help. That'll probably help. Yeah.
Okay.
Yeah. Okay. Do you see where these two are equivalent?
Yeah.
In other words, all I've done is factor this top expression by pulling out a 2x, which was the greatest common factor for 4x squared and 2x. The greatest common factor was 2x. And so what I did was I divided each term by 2x. And once I did that, that gives me that and that. Okay?
Okay.
Let's try another greatest common factor. There are basically three ways to factor something. Greatest common factor is a big one. What's greatest common factor there?
4.
What's left behind?
4x plus 4. Or plus
What you're
1.
going to do is you're going to divide each term by 4, right? That's what it
Okay.
That's what it means to take out a greatest common factor, is to divide each term by that greatest common factor. So what goes here?
4x plus 1.
What's 8x squared divided by 4? It's this part.
4.
Nope. What's 8 divided by 4? Do that first.
Oh, 2, sorry.
Okay.
2x plus
2x
or
squared.
plus 1. Oh my goodness.
And the moment you write this in your brain, you should be multiplying it back together again to make sure you got what you started with. That's always the way to do these. Okay? And that way you catch your mistakes immediately. You don't wait till the end to catch a mistake. You catch it right away. Okay? And what's the rest of it?
Plus 1.
Okay? Now multiply those two back together to make sure we did it right.
8x squared plus 4.
As long as that's the same as that, we've done it correctly. That's what greatest common factoring is all about. Take the greatest common factor out of that expression.
I think it's 1/2.
Cannot. You're right, actually. You're absolutely right. My mistake. I didn't mean to write it like that. Let's erase that 1/2. I didn't mean to do that. Now, is there a greatest common factor there?
1.
Okay, yes. But that's never a greatest common factor. In other words, you don't change or accomplish anything by taking a 1 out and writing the rest of it like this. In other words, you haven't done anything. You see why?
Yeah.
The whole point of factoring is to chop that puppy up. Okay? So, sometimes there's no greatest common factor, and you have to realize it. Now, you think for a second. It's the greatest common factor there.
There isn't one?
Well, hold on. The definition of greatest common factor is there anything that divides into each of those three terms evenly?
1. But
1, but x. I can divide x. In other words, I can divide that by x, I can divide that by x, and I can divide that by x. So what's left once you do that? What's this?
It's just...
What do you do when you're dividing same base? What do you do with the exponents?
You subtract them, so 4.
X to the 4th. Okay. What's this equal to?
X to the 2nd.
Notice I do need the sign. I need the plus sign. And what's that equal to?
Plus 1.
Right. And now notice, and you always want to do this step. You never want to go on. You always want to catch your mistakes. The secret of math is catching your mistakes as you're doing the problem, not at the end of it. Okay? So in my head, I'm multiplying those two together. I'm getting x to the fifth, which is correct. Multiplying those two together, I'm getting x to the third, which is correct. And I'm multiplying those two together, and I'm getting x, which is correct. So that's greatest common factor. Okay?
Okay.
Now, there's really only 3 key techniques for factoring. Greatest common factor is the first one. You got to master that. Then you have one called the difference of perfect squares. In other words, there's the difference of perfect squares. Why is that the difference of perfect squares? Because that's a perfect square, that's a perfect square, and they're being subtracted. So it's called difference of perfect squares. Now, how does this factor? Well, if I said a squared minus b squared, that's the difference of perfect squares. It always factors into a minus b times a plus b. Okay, so this is a very special one. So if I had x squared minus 9, that would factor into x minus 3 times x plus 3. Understand?
Yeah.
So tell me what this one would factor into.
X minus 5 and then times x plus 5.
Yeah, difference of perfect squares is pretty easy. Let's do another one. What's that factor into?
X.
No, this first term is always the square root of that. And the next term is always the square root of that. So what is the square root of 4x squared?
I'm not sure.
Well, what term multiplies by itself to give you 4x squared? Take a guess.
2x squared?
2x. If I had 2x squared times 2x squared, that would give me 4x to the fourth. But, so that's not it. But if I had 2x times 2x, now I add the exponents, that gives me 4x squared. So the 2x definitely goes there. And don't even think about the second term yet. Always complete the first term, and then the second term's automatic. It's just the same as the first term, only with the opposite sign. So, and this is always minus. What's the next term?
2x plus?
What? Well, hold on. Let's finish the first term. 2x minus what? What's the square root of 49?
7.
Now, the next term has to be 2x plus 7. Don't need to even give it any thought. Okay?
Okay.
Let's try another one. How's that factor? Making them harder, but the goal or the method is the same every single time. Your first step is to take the square root of that. What's the square root of 25x to the fourth?
5x squared.
You got it. Very good. And the first sign is always the same, the difference of perfect squares. So the first sign is always minus. What's the next term in that first binomial?
3.
Good. Now what's the next term now?
5x squared plus 3.
Perfect. That's difference of perfect squares. It's actually kind of one of the easier ones. However, there's some that can be a little tricky. Like that one. Factor that.
X minus
So
1.
Yep. Square root of 1 is 1.
So x minus 1.
Yeah, for some reason my drawing tablet just gave out.
Oh, okay.
Hold on. Let's see if I can get back here. Usually I have to do hard things like reboot. Yeah. Let's see. Hold on. Let me see if I can figure out the fastest way to get this thing working again. I think if I unplug and plug it in again, that's the best thing for me to do. Let's see if that worked. So x
Do you know that there's like a bunch of squeaking, like kind of like screeching sounds?
yeah, I can kind of hear it. It's not quite as annoying as what we were listening to before, but yeah, I can hear a little bit in the background.
Oh, okay.
So
I don't think that's from my computer though.
yeah, it's often hard to tell which end it's coming from. So what do I need to do here to get this fixed? Got 15 minutes left. Let me think for a second. I hate to have to close out, go to meeting, and reboot my computer, but that might be my only solution. Can I do that and send you a new meeting ID number in 5 minutes?
Yeah, that's perfectly fine.
Let me do that.
Okay.
I will retext you. It's got to be a new meeting ID number. That's the only way they'll let me do it.